Okay. Hello, everybody. Hello to everybody who's live in the session now, and hello to everybody who is listening to this afterwards on the platform. I'm honored to moderate this event because it's the hot topic this year, and it's one of my beloved ones. It's AI in retail. Like I said, I'm Eric. Let me just introduce myself very quick. I founded two startups and sold one last year, and my current one is right in that area. It's called Circly, and we are democratizing AI solution for retailers, solving the problem of expensive and complex access by developing a no-code toolbox for manufacturers and retailers to plan marketing, sales, and HR. But this is not my stage. We have excellent experts on this panel. So let's get back to business. There's a German saying, which is Handel ist Wandel. And if you translate this, it means retail means change, or retail always changes. The pandemic has given a rise to new digital business models, and also consumers want digitization. So companies are forced to act. A few weeks ago, I stood in the headquarters of a new online grocery retailer here in Austria, where I'm based, and every employee can read the current status quo on monitors everywhere in their complex. So what I want to say is the born digitals are coming and forcing you to act in the future. So let me introduce you to the agenda. Today, you will learn about different approaches, how AI can leverage insights and increase operational efficiencies. And of course, generate superior customer experience with technologies as natural language processing, NLP, and also forecast, for example, customer behavior. And because I'm German and we're not known for laughing and speaking too much, I would suggest we are starting right into the first presentation. First presentation is provided by Kao. Hope I pronounced that right. And Caio is a graduate from Unicamp. He studied economics there. It is a university in Brazil with a specialization in Canada. He has 13 years of working experience on building analytical teams in the retail business. And for the last 3 years, he has been employed by C&A as a head of analytics. C&A, for those of you who do not know, this brand, it's a Dutch fashion retailer that operates globally. And for the few of you, fashion also has an expiration date, as fashion is seasonal. So Caio will give us an insight into what C&A has learned from using AI to optimize product distribution. And Caio, the stage is yours.
Okay, thank you, Eric, for the introduction. Very happy to share with you guys some of our experience. I'm gonna share my screen, so please confirm if it's working. Okay, great. So starting with some numbers from C&A Brazil, we have 300 stores, more than 14 million customers in our loyalty program, and we were the top one fashion app in number of downloads in 2020. Our revenue is around $1 billion per year. And when we talk about our mission for the next years is to build a fashion tech. So understand that investing on data, on analytical teams and developing tech capabilities, it's what will make us succeed in the next years. And part of this mission is to build an analytical journey that in Brazil, we started in 2018. So just going briefly here about how we developed the teams and our journey. It started with exploration, setting up the teams and doing some pilots with the business units. In 2019, we started to develop our data lake in AWS. and we started to roll out some of those pilots we tested. And in 2020 was when we really industrialized some of the solution and started to build the governance systems and the coding guidelines. So here, in last year was really when we exploded using analytical solutions and had that on production systems. And this year, we are aiming to have more products with other business units. So we are splitting our teams inside the business units. And also we are making partnerships with AI startups to bring new capabilities and more people that can develop these solutions. For the next years, we aim to be analytical reference in the retail system. So we are developing a machine learning ecosystem and starting to build a talent pool inside CNA. That's our ambition for the next years. Talking a little bit about our architecture system, we had two environments, one for development and the other for production. In the development system, we work mostly with AWS SageMaker and AWS Step Function. It has been a good experience for us with these two solutions because you can scale up faster the code and you can manage better what's happening in the computing process. And for production system, we work with Dockers, and also we use AWS SageMaker and Step Function. For monitoring the model, basically we use AWS CloudWatch and Tableau. Some of our products we organize by 3 pillars. One pillar for price and supply, when optimize price, shipping costs, and the supply system. I'm going to go deeper in the next slide about this solution we have for supply system. Other pillar is about customers, so how we measure customers' time value, the purchase intention, and the next best offers. In the third pillar, we have a product development team working at spotting product attributes that are trending and forecasting products that will best sell us. So going a little deeper on the supply system, that was a solution that we developed inside CNA with our data science team. It was very heavy processing and a huge business challenge. And we developed that, started in 2018, and it rolled out in 2019. And it was a business case that we also shared with AWS. We did this paper, giving more detail about the solution and also the architecture we applied to process. And if you will guys want to know more, you can link here or just Google AWS CNA and you see more details about this project. So what was the challenge we had at 2018? We have more than 300 stores distributed all over the country. And when you talk about fashion business, you have a very high diversity of products. So a lot of colors, a lot of types, a lot of size, and each store you have a different demand behavior. And when we started to distribute the products to the stores, we also have to deal with different stocks levels, and we also have to deal with a lot of new products every week. So every week we have new products that have to understand the behavior and projects what the customer, if the customer will like or not in each part of the country. So a huge business challenge and a huge computing challenge. When we started, the distribution system was made by a business team. This team worked with business rules, with average mostly, and with a lot of manual adjustments, so a lot of business insights in the process. We had a knowledge of system that was inside the head of the analyst, and few control mechanisms. So if something went wrong or went right, it was very hard to understand what happened. And the business impact were huge with this system, because when you have inaccurate forecasts, you can lead to a very high or very low stocking levels in the stores. And if you have low stocking levels, it's very frustrating for the customer. She will get it in the store, she won't find her size or she won't find her color, and very bad experience. And on the other hand, if you have a very high stocking levels, you're gonna get a very crowded store warehouse, and you need to make a discount event for the next days to clean out the store warehouse. So you can go too low or can go too high. You need to really have to be precise on what you are supplying to the stores. To address this challenge, we built this squad. It was composed by one PO from the business team working with the goals, the planning, one data Vs working with the performance analysis, two data scientists building the models, the data preparation, building the tests, and also one data engineer. That was for the pilot. After that, we included more people on the project, but we started with this team. And giving more detail about the pilot, we started with a time series solution, where we built a forecast system based on behavior of each product for each store. So when develop a solution that looks at each store and sees the behavior of this specific region, we could be more precise than the older solution that was more aggregated level. And in the solution, we worked with medium and long-term seasonal effects. So you can imagine in the fashion business how seasonality is important. We have summers that change the behavior. We have promotional events that change a lot the behavior. And we start to measure that with these seasonal effects. We work with regional effects. In Brazil, we have very specific events that happens in the northeast or happens just in the south. So it was important to consider inside the model. The next step was working with product attributes. So if you have new products, you have to identify the attributes that make this product similar to the older products. And that was, I believe that was the hardest part of the model. And also we started to consider the stock levels from the stores and the business events that we had for each store. So here you can see the example about how this works. The black spots are the real events, and the blue line is the forecast. And with backtests, we started to measure how was the turning that were working better. Even more detail about the time series. Basically, it works with 3 layers. One layer identifies the long-term trend, what has been happening with this category or this store in the last years. After we have a seasonality layer that identifies the monthly events that we have for each category. So for this category, as an example, it's very strong in the summer in Brazil, and during the winter it has a low period. And we'll have a third level of holidays that were one-off events with very high impact. Black Friday is an example. So these are points that it changes a lot the behavior of the trend that are not explicited in the other levels. After we have this time series developed, the next step was to address the long-term and the medium-term trends. So for the medium and long-term trends, what worked better for us was choose a higher level of aggregation. So as an example, working with products for kids. It's a very big category, and you can forecast with high accuracy how it will behave in the next months. When you go in a more granular level, since a t-shirt or a basic t-shirt or a basic t-shirt with pockets, it's harder to predict the effects for the next 3 or 4 months. So for this level, we started to use a short-term trends. So for the long term, we go more macro, and for the short-term trend, what happened next day or the next week, we go more granular with the predictions. And the third part was to combine this multi-level forecasting. So we have the macro trend composing with the specific trend, and this combination of the trends is what really makes the difference about improving the results. As a consequence, since you are processing multi-level forecasting for each category, for each store, it demands a lot of processing power. So we started the pilot with 10 categories with 4 hours on on-premise server. And it was very slow for us to have 4 hours just to process 10 categories. And as we scale up the project, we needed to also evolve the data stack. So in the industrialized solution, that's how we operate nowadays. We use AWS machines. We have 300 tuning machines and 50 forecasting machines. They work with parallel systems. And the solution can process 200 product categories in 3 hours. So part of the challenge for us was to escalate the number of categories without increasing the number of processing time. And this change to a new architecture was fundamental for that. Going a little deeper about the results, the first results was in reducing the errors. So when we measure the accuracy, it was reduced by 61%. And it makes a lot of difference in the process system, since you have more a confidence. If you have a higher confidence level, you also can operate in a better efficient way. And the other result was an increase in the sales. What was really interesting was that the stores that we had a higher increase in sales was also the stores that had a higher degree of availability, and also the stores when we had the best results in forecasting. So it became clear that was a strong relation with improving the forecasting and also improving the availability of the products and improving the sales growth. And that happened mostly on the small stores. When you look at the small stores, they are more difficult to predict because they are very unstable in their behavior. And when we apply the machine learning system to understand this behavior, it can give better results than the business process we had before. And a third result we had with this process was the process automation. Since we have all the steps organized in the step function machine, and with the governance, we were able to understand what was going right, what was going wrong, spotting the problems, and improving the efficiency in the next months. So basically, it was that very short view about the project we had. If you want to know more, this is my LinkedIn page, my email, and I'll be in the end to answer questions.
Caio, thank you very, very much. It was very interesting to see the similarities between fashion retailing and FMCG retailing via Iron based on. So I wrote down some questions for you afterwards for the Q&A session. And please, this is an information for everybody who's listening. You should find down there an Q&A button and write down your questions. And afterwards, we are going to discuss them in the panel together. So the next step on our agenda is Douglas. Douglas has a bachelor in computer engineering and a master in AI. He's a PhD candidate in data analytics at the Dublin City University. Besides that, he's a data scientist at the Raiffeisen Landesbank here in Upper Austria. So welcome to Austria, Douglas. And he is currently Marie Curie Research Fellow at the Perform European Training Network. He's a specialist in customer behavior, in digital retail, in XAI, so explainable artificial intelligence, and fraud detection. And in the next some minutes, we will get a feeling for how you can applicate explainable AI and how the concept of trustworthy AI can be used in examples of his use cases. So Douglas, please, the stage is yours.
Thank you, Eric, for the nice introduction. I'll just try to share my screen quickly. So I hope you can see it already, full screen mode. Can you hear me well? Hello?
Yes.
Oh, perfect. Okay, great, Eric. Thanks. So again, thank you for you all for joining today. It's a pleasure to participate and to speak along with such an inspiring, lineup of researchers and practitioners today. And I'm going to talk about enhancing the customer experience online and in store with explainable and trustworthy AI insights. And also I have a brief agenda today. So the idea is to really give some motivation for why we should look into explainable and trustworthy AI in retail for enhancing the customer experience. And also I'm going to provide you with 2 examples of projects I have been working on together with some colleagues around Austria and other countries in Europe and as well as in Brazil. So just to briefly start, AI in retail is indeed reality. And when we think of, for example, returns to retailers and customers, we see that the statistics and numbers are really promising for the next years. And then it's important to ask the question, why is it so? And we can answer that by, before going deeply into explainable and trustworthy AI, by understanding that AI in retail is about understanding the customer behavior based on its past data to provide not only the customer with the best offers or bundles, but also retailers with insights into the behavior of their customers. So in fact, customers are also increasingly seeking convenience when they are shopping. And retailers need to understand their needs in this complex omni-channel era, where customers are actually everywhere, not only in e-commerce, but also social media, talking about those companies and talking negatively or positively about their purchases. And that's why we should be careful with not only using the AI for providing, for example, predictions or insights into customer behavior, but also we need to be careful with some particular examples. So because AI in retail can also backfire. So for example, you have the cases where your customer service system might prioritize customer requests from angry men over angry women, and what would be the reason for that? Or you also have the cases where your recommendations might not be matching the customer segment or the gender or the body shape, depending on the product that you are presenting to the customer. So we need to think of how the AI is actually using the criteria for learning the behavior of the customer. and what is that criteria? So this is what I would like to talk about today. That AI and machine learning retail is not only about the customer sites and providing shop assistance, but also it's important to consider the potentials of having trustworthy and explainable AI retail. And that is about not only understanding the behavior of the customer, but also respecting the privacy of that customer when you use their data, providing the customer with equal, lawful, fair, and ethical treatment, as well as keeping the robustness and the accountability, as well as the auditability of your AI model. So whenever a legal a company or department comes to your company and asks for some reports of your AI to prove that it is fair, you can do so. However, the explainable AI would not only benefit retailers, but also customers, because you can provide your customer with a shopping journey that enables transparency, fairness, and also responsible AI interaction. So those customers will be able to not only get recommendations, for instance, but also understanding why they are getting particular offers or bundles. And the question now is how this would work in real cases or projects or examples, and this is what I would like to talk about now. So we have a first case to talk about today, which is sentiment analysis online. So the idea of this project was actually to understand the customer engagement on social network and trying to identify moments of crisis. So basically, when a brand releases a product, we try to identify signals of, for example, negative comments about the product, what kind of features the customers were talking about, and features that they didn't like. So we had a pipeline which is also well known for AI engineers and data scientists, basically collecting the data, preprocessing the data with some particular text mining and preprocessing steps for treating the text and inputting it to the AI models. We trained and tested some models such as SVMs, neural networks, random forests, and then the idea was, of course, not only to provide the sentiment, but also to provide explanations for marketing analysts, for example, or even the retailers. And when we look into those explanations, we can see examples of, for instance, enabling the retailer to visualize the most important aspects or characteristics of the product that they released. And the idea here is to, enable the retailer to not only understand the attitude of the customers in general, but how and why and what they should improve in their current offers and products, and what kind of input they can have for their business model. So it's important to consider that, because you also have the life cycle of your product development, and you need to think of in which stage you can actually incorporate that feedback. So the more insights you have on for instance, the reasons for a product being not accepted by your customers, the better you can plan where to improve these aspects during the development of your product. So just to give you more explanations on this, you have the local feature importance explanations, which just give you, for example, the words that are contributing to the negative or positive sentiment. But you also have the global feature importance, which is basically which words of the vocabulary, the whole vocabulary of your corpus are the most important for the learning process of your AI. So you have different types of explanations actually, which can fit the needs and the requirements of the users of such systems. And this is also something important to consider in such projects. And I also wanted to finalize, of course, with some evaluation on this particular project. And what we did, we actually evaluated the fidelity of the explanation. So actually, could the retailers actually trust those explanations that they were seeing? And to do so, what we had a comparison between, for example, the important words, how much were they affecting the classifications of the AI. So for instance, deleting one word which was very important for the AI prediction and comparing that with deleting random words of the particular instance. And we realized that the explanations were actually, they had some fidelity, which means the retailers, they could trust and use those explanations for that particular context. But also what we are currently doing and discussing is the further insights that we can leverage out of this project. So for example, whenever working with sentiment analysis and explainable sentiment analysis, we need to be careful with the definition of the problem. So as we are, caring for having trustworthy AI, it's important to define what's a crisis at first, because you need representative data for the particular type of crisis that you are dealing with. And on social media nowadays, you have a lot of fake news going on, hate speech. So those phenomena, they can generate quite a lot of noise to your data. So you also need to be careful with this kind of noise and what it can do or how it can affect the learning process and the training process of your AI. Of course, as well as the robustness of your AI. So you need to handle hyperboles, slangs, and informalities in the language. And all those factors, when they are together, they can, bias your model, or they can make your model unfair because, for example, you can identify negative sentiments out of people which might be associated to a particular personality, and that's not really the case for considering the sentiment negative. Or for example, what happens when your company or a particular company is associated negatively to a particular personality? What's the reason for that, and how you can solve this problem actually? So those are some interesting questions and aspects we are also looking to. But this is not only the only case that I wanted to show you today. I also have this case, which is the related to the customer experience in store. So the idea of this project is to provide customers with a mobile app, which enables them with recommendations, such as we get on e-commerce and websites like Amazon, for example. However, we observed based on our literature review that there was a lack of understanding on the feasibility of such systems for in-store scenarios, and also a lack of understanding on the demographics and how demographics could influence the acceptance of such systems. So basically, what would be the target audience, or is there actually a particular target audience for this type of technology? And finally, we observed this need for transparency to customers actually. So again, not only getting recommendations, but getting recommendations with explanations. And this is what we developed. So we had a prototype with particular types of explanations within this augmented reality mobile application. And we wanted to measure the acceptance of such an app according to different customer demographics. So, for example, for the prototype, we assume that we can have access to the past customer transactions, which can be leveraged to learn their purchase patterns, tastes, and also to learn what are the features of each product that the customers have enjoyed the most. So others can also get those recommendations. And for the experiment, we had different scenarios that a user could see. And one of them had the explanations that you see now. So for example, we had explanations as item or use-based outputs, which basically explain the recommendations based on actions of other similar users. But you also had explanations related to visual attributes of the item itself. So for example, if the sole of the shoes is comfortable according to the past behavior of the user or the types of shoes that the customer likes to buy. And also we had explanations related to past reviews of other customers and the characteristics of the product which a customer cares the most. So for example, you have, with the last example, food, some chocolates, and maybe the customer is sensitive to the level of fat or other types of features. So those are also highlighted for the customer so they can make an appropriate decision if they buy or not. And as validation or results that we have got out of this example, we actually, to validate and to assess the acceptance of such a system, we used some particular models which have constructs related to the usefulness of the system, as well as the retention of the customer and trust on the explanations. And as outcomes, we actually observed that the age and the shopping frequency of the customers were impacting the acceptance, as well as the income of the customers was impacting the willingness to use such an app. So for example, the younger the users and the more they buy, the more they are keen to use such an app. But with users having low income, we observed that they wanted more features which enable further search. So more comparisons, more understanding of product characteristics. And we believe that those are aspects that can already enable some guidance on how to develop these apps. However, we were again reflecting on the importance of trustworthy AI behind these applications. We were looking to some aspects such as the fact that as we were dealing with customer demographics, it's important to be careful with the type of data and the attributes that the AI is considering the most important for recommendations and how it's handling those attributes. So, you know, for example, you might get two customers going on the same time to the store, getting different recommendations, which might be related to the level of income of those two customers, and this might not be good for the retailer itself. So those are aspects which we're also currently looking to, and that will be part of the further steps in this project. And also, and now actually, oh, sorry, I didn't mention, we had an online survey to evaluate this with 315 participants from the DACH region, which is basically Germany, Austria, and Switzerland. And from that, we got the results that I was discussing now. Maybe going to the final part of the presentation, what I wanted to talk a little bit about is just to sum up the question on how to achieve trustworthy AI. This is currently what I'm tackling on my work, on my particular PhD thesis, which is to see it actually as a process, because the idea is not to you know, ask the question, is the AI trustworthy enough I personally don't believe that that's the question. I believe that the question would be, is the world, the data, the organization, the actions, the process in the organization, are those trustworthy enough? So I believe it's actually an ecosystem and a set of steps that needed to be considered in order to, reduce bias, make the AI fair, but also considering the actions and the interactions between the data engineers, data scientists, and the AI. So, and have those considerations into mind, I believe we can provide users with more useful interfaces and explanations for their particular context and needs. So furthermore, just to finalize, I also think that as it's not possible to claim 100% accuracy in AI, I believe it's the same case for trustworthiness. So we can only mitigate threats to customers and maximize trustworthiness, but we will never be able to say my AI solution is 100% trustworthy for my customers. However, we need to consider the pathways, guidelines, and requirements for that, because this digital transformation is impacting the way we should leverage the data and become user-centric. So out of these thoughts, we can think of further questions. So for example, thinking of the supply chain and an ecosystem of trust. So who would be responsible for the trustworthy AI? Would that be the startup providing the AI solution? Is it a responsibility of the company buying the solution also to monitor the trustworthiness of the solution, as well as the instantiation of the principles that are out there from the European Union and from other institutions, as well as the need to have more interdisciplinary conversations and collaborations. So experts from different areas talking and getting together to talk about trustworthy AI, as well as looking not only to the AI, but looking to the users, who is using the AI, the data, and the processes to achieve trustworthiness, as well as this need to better combine the constraints of different regions and guidelines with each other, and coming up together with a solution which can be useful and help companies on solving their particular constraints. And of course, you have ethics. So companies also need to consider on a first place if they have ethics in place before even talk about AI ethics. But I think this is increasingly discussed. And with that, I would like to finalize with some acknowledgement and I'll again thank all the institutions and research centers involved in these projects. With that, I finalize my presentation. So thank you, Eric, again.
Thank you very much for your presentation, Douglas. It was quite interesting. I just came off a hour-long workshop with ethics professors and front runners on the technology side, and we had a long discussions about ethics in retailing, ethics in AI, and it was quite interesting. So I wrote down some questions for you as well, Douglas. Please, to all the listeners, feel free to post your questions into the Q&A section down there. And I would then hand over to Andre. Andre is not only playing ukulele or writing his blog in his spare time, he also holds a degree in information systems of the University of Sao Paulo. He is a master's student there at the Department of Computer Science, and he studies and researches in the field of deep learning methods for Q&A systems. So we are in the field of natural language processing, and because he always loved to combine the academic research with problems out of the industry, he's working for Quinto Anda since 2019, and since 2020, he's working in the customer support area with using NLP. So he will introduce you to AI and language models in the context of retailing. So please feel free. The stage is yours, Andre.
Awesome. Thank you a lot for the introduction, Eric. So let me just see. Okay, okay, cool. Okay, cool. Are you guys seeing my screen? And then I will start. So thanks a lot for the invite. It's a pleasure for me to be here and present some of the results that our team achieved at Quinto Andar. And so this is the agenda that I will try to go further and show with you. So basically, I will try to present who we are, and the issue and the solution that we try to provide. And then I'll go to a little bit further, considering the technical aspects of it, and then I finish it with some ethical considerations. So basically, what is Quinto Andar? Quinto Andar, it's not a retail company, but it is a prop tech. However, considering, so you can think it's like of, I don't know, like some kind of Brazilian version, more complete version of Zillow, or I remember that there is a UK version of it, but I forgot the name of it right now. So basically, we are a real estate company that uses technology to give solutions to our clients. But I will try to, during this talk, I will try to give some relationships when you sell about what could be done by retail industry to use the same solutions, because basically as I work in the customer support department, I mean, like, every company have clients issues, and we aim to, you would like always to give the best kind of solution to them. So yeah, this is it. So basically the idea of the Quinto Andar, it's to, our mission is to be the destination for housing. And what I mean by that, currently Quinto Andar is the biggest housing platform in Brazil. And what I mean by housing platform, we currently provide both rental, we are both a rental platform and a sale and buyer platform. So for people who want to rent houses, and either to people who buy or sell houses, Quinto Andar is an awesome place that they would go. And when you say about the rental platform, it is basically, we exist in more than 30 cities in Brazil, and on average, we had a visit schedule every 4 minutes, and one house being rented every 7 minutes. In considering an impact about it, we had more than 30 billion in under 100 billion reais under active management, and more than 200 million reais under delayed rental coverage. Because this is the main difference between considering this company, is that we guarantee that our landlords payments, they receive their payments in the correct day. So the payment is not delayed in any manner. If the tenant delays the payment, Quinto Andar pays to the landlord, and then the tenant, we ask for the tenant later. So this is one innovation aspect from our side. And then considering the for sale platform, we started to provide buy and selling houses to Brazilian people since January of 2020. And right now we exist, and we are in more than 12 Brazilian cities, I guess. And more than rental services and platform services, we are starting to get into the service part of it. So we're seeking to also provide a marketplace for housing services as well. Okay. And what I mean by this entire platform, so we provide an end-to-end solution that goes starting from the searching part, when a tenant or a buyer, a prospect buyer, they search for their ideal house. And if he or she would like to visit, we also provide the visit management. If he or she would like to rent or buy, we provide the entire transaction inside of our app. So there's a security that we also guarantee for the landlords and the seller prospects. And after that, considering if you are in the rental process, the entire management is go to the app until the end of it. And how my team works inside of it, and how does it could be related to retail segment. So basically, we want to provide the best kind of experience to our clients. And what I mean by that, it's we have a business unit, so it's called a tribe, which basically deals and try to deals with the main threats that considering the customer support flow. And these could be related to, I don't know, like some kind of my payment is delayed, I need a repairing to my house. So there are a lot of problems that can exist in the, I mean, like in the house experience. So we want to provide a solution in the best manner that does not harm the entire customer support flow as well. And then considering this business unit, a business unit is divided into different squads. One of them is mine. And my squad is basically a multidisciplinary team with 7 people. We are basically made of, I think we are one team lead, one data scientist, a data scientist. The team lead is a data scientist as well, so it's worthwhile to mention. And then we have 2 software engineers, 1 designer, and 1 product manager, and 1 UX writer. So basically, we work together to think about solutions that can give the best experience for our customers. Okay, so what was the issue that we faced off when the team was created? There was a manual ticket routing team. It basically made of 40 humans, and those humans were basically paid to read message that our clients sent to us, and then those human teams basically routes to a specific department. Okay, and this is kind of bad in 2 ways. Bad because humans, this kind of labor is tedious, because basically you are paying humans to route stuffs. So a person basically stays in the front of the computer and reads message and say, okay, this message goes to the rent department, that message goes to the seller department, and another message goes to the visits department. So this is not a useful usage of the human part of the of the work. And moreover, we also had a lot of false positives, and this results in a lot of transfer between departments considering the ticket subject. And then we had at that time around like 56% of transfers, and this is bad because there is an inverse correlation considering the good experience to our clients, and I mean like the rate of ticket transferring. So this is the solution, not the solution, but the pipeline that he had on that time. And what I mean by that, around 65% of the messages goes through a specific campaign or a WhatsApp message that goes to a specific QE. And this QE is basically, we had a set of heuristics that points to the specialized analyst. And we have the 35% of the tickets going to this team of 14 people. And what we provide a solution, we provide an AI platform, or actually an AI solution, which is basically an orchestration ML flow with a BERT as a backbone. And this started to receive 90% of the demand and goes to a specific query as well. And then basically the query points to the specialized engine. We had around 9 departments and we obtained around near 90% accuracy. So this is one of the good solutions that we had. And when we consider the transfer per ticket, so in other words, given a ticket, how many transfer it would be, the previous heuristic systems that we had around 22% of the transfers. And those Citadel is basically the name that we gave to the model. So if you see Citadel here or there, Citadel, it means the model that we deployed, and the results was kind of similar to the human one as well. And moreover, the message, we need less messages to these AI systems to have the same solution, to provide the solutions than a human team one. So, again, basically the same amount of transfers. It's basically competitive to the solution when you consider the 70% here and the 17% there. And if you see, the model received 3 times like the numbers considered to the human. So it could handle more messages and provide the same quality when you consider the final results. And then consider the business metrics, the drop, we got a drop ratio in the transfers that went through from 56% to 26%. And this is the ethical aspect for that. No one got fired. This human department, the entire human department were relocated, and then those people that initially was contracted to basically see if a message should go to department A or B, now they are basically relocated and trained to be an specialized agent whose responsibility would be to provide solutions. So basically you have a human that tries to actually give a solution to a problem and not just read a simple message. Okay, so basically this is, I told you about BERT to you, and then I will try to explain a little bit BERT, what is BERT for those who are not familiar. So think that you have a message, and then we have some kind of pre-processing step message, basically, for instance, tokenization, and then after you tokenize the words, you can map them to integers, and those integers, okay, so basically if you see around here they are mapped to the same integers because this is a direct mapping. And afterwards you have this works as an interface for a simple lookup matrix, and this matrix can be random or be learned. I will get in the learn part as well, but you can think these interest matrix are just simple lookup matrix. And this is what you call an embedding matrix, where the number of the rows is the vocabulary that you have, and the number of the columns is the embedding of this, it's the dimension of this embedding. So this is an introduction of what is embedding. And then if you want to train, that is where BERT comes from. BERT is a sentence level embedding encoder. I think that I can say, I could define it as that. So basically you tokenize, again, same process, you tokenize this embedding and then tokenize the word. Those words, you have some special tokens. Those special tokens are tokenized as well. And these kind of words serves as, so this is a sentence, as I said, BERT is a sentence level embedding. And then this works as an interest to a neural network. And how does this neural network works? So I have this input embedding, and then after that you have some kind of positional embedding, which basically tries to give some notion of the importance the importance of words relative to its position. And after that, you enter both position embedding and the input embedding, they get summed. And this serves as an interest to the encoder model and what is the formation of this encoder model. So you have a multi-layer, it's a multi-layer network, and the first type of it, the first part of it, it's a multi-head attention model, and then you have some kind of normalization layer, feed forward with basically a simple MLP, and then another normalization. This composition is basically one encoder layer, and what BERT basically is it is a stack of different encoder layers. In the most smaller version of BERT, n equals 12, and the largest it is 24. And what do you get after that? It's the embeddings for each token in a sentence. And then the main advantage of the BERT model is that the COS embedding, so this special token, can work as a summary of the sentence. So this is only the embedding of this token works as a summary of the entire sentence as well. And then this is why BERT is a sentence level embedding. Okay, so I skipped the details about it. If you want to look, please take a look into my personal blog. This animation is I've taken and put on there with the further details if you want to learn more. So how it works when you consider an entire pipeline. So basically a user sends us a message, you have a message parsing system, which basically gets the user phone and the income message as well. I'm sorry, this is in Portuguese because this is a real example. And then just believe me that here you have an income message, and then you got the user phone. Basically, you have a kind of feature database that you can query, and this return to you some kind of metadata with respect to this user. So given its phone, we can learn, okay, what kind of contact he or she made up in the last time they contacted us, or he is or she an agent, or he's a tenant, he's a prospect buyer, I don't know, like any other messages. And then we have an income message as well. This income message and the metadata, they both are fed into a ML model, which is basically the BERT encoder part. Basically, it's the less hidden layer of the BERT model, concatenated with a metadata vector. Both models is actually this is a single model. It's a single neural network that receives both layers as inputs, and then this MLP, it's basically ML model, which is a MLP, and this MLP learns to differ between different kind of contact motivations, and we have around 300 classes, and those 300 classes are mapped after the training to specific departments. So for instance, here we have this message and metadata. This is classified to a single contact motivation. Then this contact motivation is mapped to this department. And then, okay. Yeah, so basically what those familiar with NLP might say, does it scale? And because BERT is a really huge model, yes, but what our solution provides, okay, BERT is heavy, and what if BERT becomes a backbone of a larger system, and these large systems become the backbone for different solutions, you know? And then I go into the details of this second part. And okay, so basically we have a single model, and then this single model provides different solutions given the problem of that our customer is facing. So basically you have an introduction. We provide an answer to the user, and then first of all we have a context modifier model, which is simply a logistic regression model that, given the message, it tries to define the probability that this initial message has enough context to solve the client issue. If not, we have a kind of, again, sorry for the Portuguese part of it, but basically we have a kind of clarifier model. It is not a model, it's more like a state machine approach that asks for the user for more context. And if he or she gives more context, we fed it again to this logistic regression model. And if the logistic regression model says, okay, you do not have enough context yet, we basically send it to a human. We do not want to get the user stuck into loops, you know. So basically we develop what I mean by ML workflow system. It's basically a state machine actually that we have different steps that given some where the customer is located in the flow and the message, what kind of context do we want to either provide to him or asks from them. Okay, so going further, let's say that the context model says, okay, you have enough context, let's go deeper. And then we have a kind of ML flow that we provide a classification model. This classification model decides what is the main motivation context of that customer, and then we basically maps afterwards this context motivation into 3 different aspects. And those 3 different aspects are, okay, the customer has a doubt, the customer wants to receive an information, or the customer has a request. If the customer has either an information or a doubt, we basically had a kind of reader retriever approach, which basically retrieves through our FAQ, most frequent, it's a FAQ, you know, and then it's a FAQ system, which basically provides some kind of documentation that can give quick answers to the user. But instead of asking to the user, okay, did you check the FAQ already to see if your problem was already explained there? So instead of us to ask from he or she to do this, we basically do this from them, and we retrieve the facts. Given a document, we provide a machine-ready comprehension model to this FAQ, and then we try to find the paragraph or the sentences that actually tries to answer the question of your user. And so this is one part of our systems. And the second one is that, okay, the user has a request. How could we point to a form that he or she can fill it out, and then the request is already processed, and we start to process it actually in a more automated way. And if given those kind of try to solution or kind of solutions, the user is not satisfied yet, we actually asks if he or she needs more help. And if the answer is yes, we point to the best department that there will be a human that will solve the problem for them. And if not, we basically say thanks and bye-bye. Okay, and another thing that is worthwhile to mention is what's the channels that we provide. So this entire flow occurs through WhatsApp or an in-app, in both WhatsApp and an in-app solution that we provide. Yeah, okay, so I have this final solution. Again, those are in Portuguese, so basically believe me that this is some kind of exchange messages that the green ones are the ones that the user sent, and the gray ones are the ones that our automated system answers. So there's a greeting message. Okay, so kind of good morning, and then we present ourselves. Okay, good morning, I'm the virtual assistant of Quintondar. Could you please tell me what is the message that you want to tell to us? And then the client describes its issue. And then we basically, okay, we find that as a potential issue that have a solution, but this is not automated. And then as it is not automated, to help it go faster for the human agent to provide a solution, we ask for some metadata about this user. So basically we ask, okay, do you have a register? Are you already our client or not? And if he or she is a client, we ask for some kind of data like actually the number, the phone number, or other kind of words. There is a kind of, I don't, I'm sorry, Doug can correct me, but I think that is some kind of regulatory data law in Europe. So you have a kind of similar one in Brazil, which is called LGPD. And then we ask those questions to be concerned and related to the LGPD necessity. And then after that, after we got this kind of messages, those are kind of contexts that are given to the human agent, and then the human agent could provide the best solution in the fastest way. So this is the WhatsApp part, and then the in-chat solution part, there is one step above, because before we try to point the people to be helped by a human, we try to automate the solution if the solution is easy. And what I mean by easy is that if you have a question that a lot of people asked before, it basically we try to answer it in a common frequent asked questions document, which is a FAQ, and then we try to provide the point of the sentence inside the fact that gives the answer to the user. Okay, so basically in the blue one is us, so we are presenting ourselves, are the virtual systems of the Quintonar, and then we ask in the gray for the user, and here the user is asking for a repair, and then we point out to a kind of documents, and one of the documents, okay, how could you, our house needs repair, what do you need to do? And then this kind of here in lighter gray, it's the part of the solution that we think that solves the issue, which is basically, this is the entire FAQ if the user wants to read more. And this part of it, it's basically located here. As you can see, those are the same words. And then, so this is the part that we believe that contains the solution. And we ask, okay, this article is useful for you, or do you need more help? So basically, this is one question. This article is useful for you. And again, do you need more help? And the user can click either yes or either no. If he clicks yes, we then goes to some kind of point. I did not click this. I did not provide screenshot for this, but basically we have another message that is saying, okay, if you need some assistance, you can send us a message through WhatsApp, or either call to us, or either send an email. You basically find out what would be the best kind of channel that gives a solution for this user. Okay, so basically just to finish, some ethical consideration aspects for it is that at Quintonar, we do not want to automate the labor, the human labor. We want to help or enhance it. So as I said before, it is kind of tedious to you contract a human, and the human would be like the entire day basically reading a message and say, this message, okay, this message goes to department A or B. And this is kind of a bad usage of the human time. The human would be better utilized if he or she spends his time working, actually trying to solve a problem. And this is what at the customer support team we try to do, or construct those kind of the solutions. And just a provocation side, I mean, us as a data scientist, it's our responsibility to have this kind of considerations into mind, so this kind of ethical consideration in mind. I just would like to point out to this article from Rachel Thomas, which is basically, I will just quote her article actually. She basically asks us, how can we develop less biased ways to make decisions? And then we want, in the final in the final of the day, what we want to do is how could we combine the humans and the algorithms, and considering that both together can help us to give less biased solutions, or take less biased decision-making process. So this is the kind of, this is the cultural aspect of Quintandar when you're considering to building AI platforms. Okay, so what about the retail aspect? Just to conclude, I told you about, I brought here about a customer support team related to a prop tech company, but we can abstract this prop tech part. We can basically provide, as you are retail practitioner, this same solution can be provided to your industry or your problems, because basically what we are trying to do here is use AI to help our customer support aspect of our industry to scale, and I think that this solution is agnostic to the domain. And yeah, that's it. And thanks a lot. Please feel free to reach me out, and those are my contacts. Again, thank you all. Thank you very much.
Thank you, Andre, for the very detailed presentation of your topic. It was quite interesting. But I would then proceed to the next presenter. It is Gültekin. And he's not only a researcher at Ivy at the Maynooth University in Ireland, he's also researching with Douglas in the Perform European Training Network. And his background is more on the business side. He has been involved in several consultant projects, and his interest and his publications are handling about the retail apocalypse. So be ready and prepared to listen to his topic because he's investing in strategic barriers of assortment integration while pursuing an omni-channel retail approach. And I think that's very interesting. So in the upcoming presentation, you'll get a feeling for how analytics insights drive innovation and transformation, and Gültekin will show you the use case from Ivy. So Gültekin, please share your screen and start your presentation.
Oh yeah, thanks, Eric. Thanks. So I just muted. I didn't notice. So thanks for the introduction, and thanks everyone, the previous speakers. Very interesting insights. And as Eric mentioned, so I'm going to focus more now on the business aspects in the notion of psychographics analytics. So I'm going to scope a bit out and then look into how we can actually apply this type of analytics. So let me just go full screen. So it's fine, right? Yes. So as Eric outlined, so I'm working at the Innovation Value Institute. So I'm a researcher within the Digital Retail Research Cluster. We have different research objectives, a whole research agenda. We're looking into the digital transformation of the whole industry from an ecosystem perspective. So, but particularly our goals are aligned to look into strategic aspects, how we can actually adapt to the circumstances by, adjusting or innovating our business models. We are particularly focusing and building expertise and applying expertise in the technology domain, and of course, within the whole transformation process, where I locate or position the analytics part. So first of all, let's have a look at the notion of psychographics, what it is and what it is not. So we need to step back a bit and think about how marketers out there, how they segment their target groups. So you're a business and then you want to segment and structure your audiences. So a typical approach is the demographic one. So, and it's the most established one because it's obviously also the easiest one. Somewhere in your data, you will find all this information. So age, gender, income, education. So this is quite established in the conventional marketing domain, and it's still relevant, of course. this is supported by so-called geographics. So geographics, as the name says, looking into more in the local, in the space domain. So it's a country, region, city, what type of community, is it a closed community, or specifically the addresses, so which can give you more information. For example, about the building, so which might also be relevant. And one of the most important and relevant information you want to have as a retailer is, of course, the behavior in the shopping journey. So you can distinguish the target groups across different types of behavior. This could be looking into the customer journey. So in the context of omnichannel retailing, for example, where all channels should be integrated, there's a phenomenon called channel hopping. So does your customer hop from the on and offline channel, from on and offline to mobile channel while being on the purchase journey or not? So these are the questions. You look into the behavioral data and other habits, of course, like payment or involvement. So how much time do those people spend in their shopping journey, usage, reactions? So what are the after sales reactions in social media? Are they actually returning customers or not? So these are very, very important. One of the most significant studies in the retailing domain. However, we're going to focus on the notion of psychographics. So psychographics, as the name implies, addresses data involving personality, attitudes, so general interests and traits, emotions and lifestyle. So you really want to know what are the motivations behind this. So what I just show, like other 4 dimensions, there are many other taxonomies out there, even there are like, combinations also, which is actually should be desired and gonna be the main message out of this presentation. Anyway, so let's have a more deeper look into the term. So as I just outlined, it's a study to describe human personality traits. So based on what they're actually doing. So what are they motivated by, its beliefs and lifestyle. It's in addition to the demographic and geographical and as well as behavioral data sets you might receive. And why is it interesting? Because the psychographics are more suitable, are more appropriate to actually give you information about the motivations of those target groups. So obviously you want to know why they're actually shopping this way, why they're actually shopping that often or spending that much time in the store, etc. So it's addressing the why question. So the utility is obvious. So you might want to retrieve the psychographical profile, because you will have a much sharper understanding, a much better understanding of your customers. So if you have this profile, you can tailor your offerings, your communication towards those individuals, and thus increase the relevance of whatever initiative you have. This will also increase the likelihood of the reactions of a response and engagement. And within the retailing and many other contexts, obviously we aim to convert these reactions into transactions and at the end to sales and profit. And today, now we have the ability to opt to concepts from the AI analytics domain, machine learning concepts, etc., which can help us to retrieve and analyze those psychographical profiles. Back in the day, in the conventional marketing, which is still relevant today, most information was just retrieved through surveys, focus groups, observations, things like that. However, today we have much more opportunities to do so. So I'm going to look to show you more about the backgrounds and the most used frameworks. So obviously, if you want to have a look at the deeper insights of your customer group, you want to organize along some dimensions. And for those dimensions, there are plenty of frameworks out there used for different contexts. So first of all, as mentioned, the term is originated from the marketing discipline. It was coined somewhere in the 80s. There's a counterpart in the psychology discipline, which is referred to as psychometrics. So not to confuse psychographics with more into looking to the medical aspect of those terms. And why did it emerge? Obviously, people wanted to start to have a better understanding of their target groups, and of course, at the end of their strategies, they want to have a better positioning compared to their competitors. Oh yes, so there are like conventional techniques to use factor analysis, cluster analysis, canonical correlations, etc. But today, this can be automated with means of machine learning tools. So coming to the different frameworks, so I'm not going to detail here to describe each framework now. I just want to show the different shapes of them. So what you see here is very interesting. This is one of the earlier models trying to map psychographical profiles along different dimensions. Here we have 2 dimensions along resources and innovation. So resources as in the individual have high income or opportunities, freedom, flexibility, things like that. And innovation as, the customer is able to, for self-fulfillment to achieve ambitions and goals, etc. So likelihood, etc. And along these dimensions, you can position and describe those personalities, and they're labeled as thinkers, strivers, makers, achievers, depending on what positions they might have in the matrix. So this is very, very typical for those frameworks. So you get labeled with some describing a term like, believers. So, and this comes along with a lot of more keywords. It's going to be useful for profiling. The next one is a most used one, and I think most of you are familiar of this, the Big Five model. Probably, if you heard of, the Cambridge Analytica scandal, so to say, they used actually this Big Five model to map the personal profiles of the customer. So there are like 5 dimensions, and in these dimensions you have like one extreme and the other extreme, and with describing the personality, describing features. This is a limbic map. This is a very, very powerful and very popular by brand managers, because this is based on a studying the actual limbic system of human brain. So if you're familiar with the term limbic system, you might, you remember, okay, this is the oldest part in the brain. This, this is heritage, from the evolutionary point of view. Back in the day, when life started on Earth, the reptilians, they developed this limbic system, very, very dominant in the unconsciousness of your human brain. And this model framework actually provides you 3 sectors and describing this emotional system. And these 3 sectors are divided into the stimulant sector, the dominance, and the balance. And there's a mix between them. And as you can see, all these attributes describe the personality of an individual. For example, if you look at the top of it, adventure, a thrill-driven personality, you might want to treat and address those personalities differently compared to, let's say, the disciplined and controlled one below here on the below right. So this is very, very interesting when it comes to positioning your communication and even your product offers. This is an example application of it in the retailing context, and you can see, how different behaviors are actually mapped to those personality sectors. So as I mentioned, so in the adventure, thrill-driven sector, you might associate experiential shopping. And on the right side, you would see efficient and power shopping. So efficient as in, you want to have full control of your shopping journey. You want to get in, get out of your shop or the web shop, whatever. This is what counts for you. And this is really important if you want to design such a workshop or design your store. Another very, very famous framework is the Hofstede's cultural dimensions. This is very popular when it comes to internationalizations. So this is addressing the heterogeneity of cross-cultural communications. there are 6 main dimensions. So it all developed to 6 dimensions today. It started with some huge survey undergoing in the 70s conducted by IBM. And exemplary, you see the comparison of Germany and Ireland along those 6 dimensions. And it looks like they are like, quite similar. However, on the domain of uncertainty avoidance and indulgence, you see differences. And this is where your implications come into play. So you see, for example, on the long-term orientation here, so the typical for German audiences, so there's a high long-term orientation evident in the culture versus an average, I would say, in the Irish culture. So you might think of, adapting your offerings based on these insights if you want to internationalize to Ireland or the other way around to Germany. And there are other frameworks as well, so I'm not going to show them all of them. So emotion maps are very popular. There are like different, degrees, how emotions are evident. However, the right one here, this is very, very interesting when it comes to applying those frameworks for analytics concepts, because this is called, what is it called? It is called the emotion keyword wheel. And you see in the middle, like 1, 2, 3, 4, 5, 6, 7 key emotions and associated keywords with that for personality. Really, really helpful and valuable if you want to build ontologies, keyword corpuses, etc., based on emotion frameworks. So there are popular use cases out there using psychographics. For example, Procter & Gamble, they recently looked at their data. So Procter & Gamble is the dominant FMCG provider in the world, and they're sitting on 1 billion consumer IDs. So this is a crazy number, actually. And now they realized, okay, let's analyze those data, what's uncovering. So very, very interesting. And they coined the term propensity marketing. So this is basically nothing but what we understand from machine learning, the associations, the degree of correlations, etc., among certain concepts. So the result was they developed over 350 microsegments. So based on the psychographics they utilized. So before that, they were just, around 30 or so segments. The another famous application was, as I mentioned, Cambridge Analytica case. So they started analyzing huge amount of Facebook profiles and mapped them according to the dimensions of the Big Five model. And, there is a lot of controversy around this case. However, we know the outcome. So based on those findings, the insights, they were able to target those profiles within their campaign. And we all know what the outcome at the end was. And the last one is what I want to show is like the TikTok app, the TikTok phenomenon. So everybody knows TikTok right now. Its popularity is increasing tremendously. And one reason why that is they actually made psychographic analytics of the key audiences. So their key audience is actually Generation Z. So we all know the other generations, maybe, the millennials. And demographic-wise, there is not that much of a difference like millennials, other than age maybe, and Generation Z. However, there are huge differences in terms of psychographics. So millennials are predominantly, on Instagram and Facebook. They want to portray themselves in a perfect way. Just think of those, generic Instagram pictures that are so smooth, perfect, showing a perfect world. Like, I'm just stereotyping a bit. Versus more the creative and authentic portrayal of the Generation Z. So if you make use of TikTok a bit, you will notice that, there's a lot of stupid things going on. And, but that's like the way of expression for the new generation. And this is interesting because TikTok tailors the features of their app according to those demand to this profile, right? So finally, I want to show a small application case. So currently we are having like 2 projects where we applying psychographics. The first one is in a beyond conceptualization phase, and the second one is within the conceptualization phase. So this is a retailer. The retailer is positioned in a high price segment, and it's customer centric. So customer centric means they're highly interested in profiling their customer groups. So what we see on the left side is basically the collection of the data sources. They have like different sources for data. They have the CRM system, they have reporting tools from the content management system, royalty programs, point of sale. So there's a web shop as well as brick and mortar stores. From their marketing systems, payment data, Google Analytics, third parties, and of course, they're also doing constantly surveys and focus groups. So when you look at the beginning of, the definition of your target group, a typical approach is that you actually define a so-called persona. So a persona is basically a depiction of your typical customer, which you want to have addressed. Then, cross-matching that with the actual customer profiles can reveal the deviation, etc. However, in the middle, what you see is a keyword collection and the association. So it's an ontology based on those insights to be developed. And the next step is going to be to look into social media data. So the idea is to do the same, like not really the same like Cambridge Analytica, because that's not possible actually. And, retrieve so-called hidden traits and interests of those profiles. At the end, you will have a collection of explicit and implicit attributes. And that's where it's getting very interesting, the implicit attributes. So these are the keywords and personality traits associated with the explicit attributes. And at the end, you will have a holistic customer profiling. And if you notice, this is a combination of demographics, geographics, behavioral. So in this example, we see a high average transaction value per transaction, time spent, etc. And below you see the idea is to map those attributes to the Big Five model. There are a lot of studies out there who actually allow to map your frameworks according to across different types of social media data. And the improvements are visible, so mostly optimization. So you will be able to learn about the channel behavior. So when you look at this example, for example, so this person is efficient, for example, and organized. So this person might consider, shopping on an online environment much more efficient. So these insights can help you to, improve your business in different aspects and designs. So just to conclude, the key takeaways that you really want to enrich your target profile with psychographic components. This will allow improved customer experience and at the end also improve your return on investment and your initiatives. And do not fear to apply AI tools. There are a lot of tools out there. So for example, IBM Watson, etc., can help you to explore this domain. And what's more interesting is to discover hidden traits within your personal target group profile, because they can actually uncover the real interesting opportunities. And at the end, this will result in a more competitive positioning in the market. So that's all from my side. Thank you for your attention. I just want to highlight some 2 events, if I'm allowed to. So we're going to have the huge Perform European Digital Retail Summit, June 18th. And for the academics, and not only for the academics, also for the industry people. So if you have developed some white papers in the domain of digital retailing and HCI, so we're having a workshop conducted in October this year. And just contact us, Douglas and I, we're on board of it. And yes, that's about it from my side, and some engagement channels from IVI side. Thanks.
Thank you very much, Gültekin. You stole my next slide.
Sorry about that.
Let's jump over once again to the agenda. We are going to the panel discussion in a Q&A session. So if you have any questions regarding the presentations today, please write them down into the Q&A section, and then we are going to discuss it with the panel. And I think Gültekin mentioned the upcoming event on the right side, but not the next webinar on the left side. So on June the 3rd, starting at 12 is the next webinar with the topic competences and capability, professionalizing IT for transformation in the digital decade. So I think that is a very interesting one. So register now, and then like Gültekin said, here are some engaging topics. Please feel free to follow Ivy on several channels, and I would then resume the day. So let's wrap it up. We got some insights about demand prediction, enhancing customers' experience with XI and NLP, and at the end we had some insights of customer analytics and targeting. And now let's check if there are some questions in the Q&A, but I don't see any. So I would then stop my screen and would jump into an open discussion for the next 15 to 20 minutes with the experts. And I was a little bit surprised, Kaio, about that you are using Amazon Web Services, because here in Austria, and also I know from some customers in Germany, they are sometimes afraid of the big competitor, because Amazon is not only hosting web services, they are also in the retail area. So please give me some insights why you choose to buy and not make your own data center.
We use AWS mostly for processing data, and that's a business that is not our core business. We are at CNA in the retail business, and when we talk about cloud computing, it's another matter, it's another skill. And for us, was a way to get more velocity on deployment, the projects. When you see other startups that are developing solutions, they are also using AWS or Azure or other clouds. So when you are plugged in this kind of infrastructure, it makes it easier to join forces with other companies or to bring people from the markets that already know this technology. So that was the motivation for the decision.
Yeah, that is pretty interesting. Here, like in DACH region, so Germany, Austria, and Switzerland, you get red flagged for working with AWS. So it's very interesting to see the different culture and the different approach from other countries and other companies, especially that CNA is a Dutch company. I was a bit surprised, but yeah, thank you very much for the insight. I have other questions. Or is there any
could I just make another point? Because I think in Brazil, when you consider cloud computing services, it's really interesting that you say that, because here I think AWS is the biggest one. So at Quintonary, use AWS as well. And inside Amazon, they actually treated those are two different companies. I mean, like either inside, because I have some folks that work at Amazon, and one company is Amazon.com, and the other one would be AWS. So it's interesting to see this opinion from the European folks.
The European retail industry is a little bit afraid of the challenge from the side of Amazon, that they are entering their market and then steal the market share. So I think that is the reason why they are scared of AWS, because they would then could use the data to disrupt the market. Mm-hmm. And even they entered the market for grocery retailing here in Europe. So I think that is one of the points that I have.
When you guys think about cloud compute services, or even like huge data processing kind of pipeline, do you usually build your own data centers, or do you go for Google Cloud Services or Azure? What is...
Azure and Google is the go-to if you need like a ready-to-go structure, and if you have the cache for it, you then tend to do your own business data center. Some of the big retailers also have decentralized services from European service distributors. So it's quite interesting.
Cool.
So the next question would be, Douglas, you showed us the Shapley values, and I know out of my customer meetings that every customer loves these Shapley values because they give you a feeling for how are the features performing and what is the most important features. Is there any further step forward besides the Shapley values that you would recommend or would take a look on? And then the second question would be, where would you implement the explainable AI first? So where in the value chain of like data analysis?
Thank you, Eric, for the very interesting questions. So regarding Shapley values, I think maybe from more broad perspective, you know, that's a very highly cited paper, and like many companies actually use that, or they develop some libraries out of that with a similar approach. However, what I see from the academic perspective is that researchers in explainable AI, they still value more the performance of the model, or you know, if the explanations are really attending to the reasoning of the AI. However, what I see as potential next steps is really to, before deploying explanations, talking to users, understanding their requirements, because it's not about just using the model, deploying it in a decision support system, and asking the user if that's useful or not. I believe it should be the other way. And this is what we are doing at the moment, actually. So we use different requirement solicitation methodologies to talk to users, understand their decision-making process, and see if the existing explanations actually can attend their needs, or if there would be a need for developing different interfaces or the combination of those explanations. And the other question you mentioned regarding the explainability, where it should be, I think actually people are still trying to answer that, to be honest. So I don't think I would have a final answer for this, but I believe we should revise the life cycle of data science projects. To be honest, I think it's about promoting the awareness of the importance of trustworthy and explainable AI. So it should not be only the data scientist, but it should be also the business, the manager. They need to understand what AI ethics mean, and how they can collaborate and talk to the developers in order to, you know, develop solutions which are at the same time well optimized for the problem, but also are lawful and would not harm society or the customers. So I think that's like a good way to see how it could go in the future.
Thank you very much. You mentioned performance versus explainability. We've all been in several projects, and I would love to know your ranking of the performance and the explainability. Which one is more important when you talk to a manager, for example?
Yeah, that's a tricky question, to be honest. But I really think it depends on the context. And nowadays, if you look into the new European legal framework, for example, they are classifying AI systems based on risk. And for each of those risk types, you might have a different trade-off, you know. So in healthcare, of course, you need to have a good performance, but explainability is essential, as that the application is going to deal with the human lives. But on the other way, you might have more, you know, performance being like considered as more important than the explainability. But I think, to be honest, I think that you should look into the requirements, the EU requirements, for example, which are like related to lawful, ethical, and respecting human beings, and also keeping the robustness of the AI. I believe that if you have those requirements attended, like I think that's sufficient for deploying the AI solution with not so much, without being so afraid of having any harm or issues with legal entities, for example. Because sometimes, it depending on the model, it's difficult to make it explainable, like deep neural networks. Of course, now we have many different methods for that, but you need to be conscious of these aspects. And of course, again, consider the context to have this trade-off.
Thank you. And jumping from life science to fashion retailing, or more to customer analysis, so Caio or Gültekin, what is more important, explainability part or the performance? Do you want to know more how the model was deciding on which feature, or is it more the performance of the model? Please feel free.
Yeah, yeah, if I'm allowed to start. So basically, this is a good question when it comes to assessing, evaluating the relevance of the performance of the targeting. So in conventional marketing, you have this phenomenon, what's called spillover effect. So that means you might, reach out to audiences you actually did not intend, or other campaigns would spill over to your campaign, and then there is a small mix of unidentified performance of your campaign. So with that, I would say, in terms of advertising, etc., and communication, it would be more towards the performance. So it's okay for me if there are some indifferent audiences addressed. However, when it comes to when you want to assess, evaluate your return, let's say you have like a tight budget, etc., obviously you really want to have this this minor margin of errors in your advertising or campaigns or whatever. So I would say it's depending on the policy or the the principle in how you handle the budget.
Thank you. Caio, would you like to add something more from the fashion side, or shall we shoot the next question?
I'd say that one of the biggest challenges when evaluating the results is to make it clear to the business leaders, because in the end, you can have the specialists looking at the results, and if just the specialist understanding or buy the conclusions, it's very hard to move forward. So in my experience, biggest challenge is explaining the results to the decision makers, and it's not easy. Sometimes you have the result, you understand, but make it understandable, it demands efforts.
I think so too. And Caio, I would then jump to the next question, and that one is going to you. Machine learning or deep learning to analyze your demand. Which technology and why and where? Do you differentiate between short and long term, or do you have specific operations with the technologies?
I had some interesting experiences with that, because when you talk about millions of products and hundreds of stores, and you start to get on point that processing time becomes an issue. And I had this problem in the beginning of the project, because we were forecasting for each store, for each product, and a huge amount of processing time. So when you try deep learning, it went like a lot more effort and a lot more time processing. It became didn't make sense for our operation to go in this level of processing in terms of the leverage we had in the results. So for our case, in this case, because we're very granular in the forecasting we're doing, more simple rules were demanded less time, and time in this case was important for us. So in our case, machine learning was enough and attended the demand it had for processing time.
Great, thank you. Andre, do you think that natural language processing will kill all the call centers worldwide?
Whoa, tricky question. And I don't think so, actually, because I think that the most use that you could make of natural language processing would be to kill the, I mean, like, the easier problems, you know? I mean, like, okay, so let me give you an example. Let's say that a customer enters in contact with you that to ask a question if he or she read a simple I don't know, like a simple contract, it would not be necessary to provide a human to answer that to them. So I think those kind of easy problems could be solved by NLP or NLU kind of solutions. But in the end of the day, real problems or real issue or complex issues are kind of far away to be solved from NLP. I mean, like, either if you get the most state-of-the-art results, let's take, for instance, GPT-3 that got launched by the OpenAI community. And if you like analyze its behavior when you consider really complex or tricky situations, it has some real issues, either considering kind of answers, complex answers, or reasoning that involves some reasoning, for example, or either considering ethical aspects, you know. So we are kind of far away to provide NLP solutions that requires some kind of more knowledge, you know, to give answers. I mean, like, this is basically my master's kind of research. So yeah. You are mute.
This would lead me to my final question. I would then ask everybody of you to find an answer for this. What is your current biggest challenge in your field, like NLP, XI, and demand forecasting, and then of course Gültekin, your field of customer analysis? Who wants to start?
Well, I can start.
Please, go ahead.
I think, okay, I think the biggest challenge considering the NLP field would be to build agents that are actually intelligent, you know, because when you consider the learning part, it basically learns to how to repeat patterns. And when you have questions, I'm sorry, when you have questions that indeed require some kind of complex reasoning or multi-hop or entailed reasoning, their performance is really, really bad. Even when you consider in some kind of questions that let me get, I mean, like, more than a factual stuff. I mean, one thing is to ask an agent, when does Barack Obama was born? And another thing was, if you, I don't know how to say this in English, but how could you warm your hand? And the answer would be like, you need to rub them, you know? So this is kind of questions that an NLP agent is not able to solve because it involves some more reasoning than just factual answer. I think this is one of the most interesting and complex challenges that we have faced right now, that you face right now.
Sounds like a problem to solve. Douglas,
Yeah.
please go ahead.
Yeah, sure. Maybe trying to be short. I think what is interesting is that I think the biggest challenge in transfer of AI, if I talk about that, is the definition itself, because you have different perspectives on that. It depends on who is using the AI, what's the application, and also this need of aligning user requirements to current explanation methods or even AI methods, and also this interaction, between them, because in the end, it's not, as I said before, about providing explanations and let the users use that, and it's done. It's a cycle. It's about the human in the loop. It's about helping the AI improving over time, and helping the user with this decision making. And for that, we need explanations which are useful, which can help in the context of the user, but which also respect the requirements regarding the robustness. So aligning this trade-off, actually, that's the biggest challenge, and as well as the definitions for how to work with trustworthy AI in particular contexts.
Great, thank you. Caio, you're next.
I believe for everyone that's working with time series forecasting, and 2020 and 2021 have been challenging years. You can imagine the stores closing down, people changing their behaviors. It forced us, and I believe everyone, to adapt their models, to start collecting more information, more real-time information, because it just can base the seasonality of the last month. So it changed everything.
So it's a little bit the polluted data out of the last years. The missing product, or the most bought product in Austria, was toilet paper noodles. So that's a fun fact. That depends always on the country. And here it was toilet paper noodles. So very funny. Gültekin.
Yes, indeed. Yes, so in my domain, so I can't stress out, I can stress out that the most, I would say two things. The first thing is, like, for retailers, even for SMEs, having the actual awareness that these things are not related to big resources anymore. So back in the day, you would have to have like a huge department of market research, some market intelligence department, whatever, with skilled people also from the research side. However, today we have so many tools, we have so many opportunities to reach out to those data. And this is also could be easily done by SMEs. So this needs to be aware more clearly and more broadly in the whole industry. And the second thing is, that comes along with that, so this is very important, to actually develop the mindset and capabilities what comes along with that. So obviously, when you want to utilize those AI tools, when you want to have an understanding of different unstructured data, etc., you really need to have those new type of skill sets and capabilities or resources, also from technology side, built into your function and whole value chain, actually. And this is something which is evident in a whole business transformation literature and culture, that there's concepts like path dependency, etc., which inhibit this. And this is the biggest obstacle in general, like the change, being aware that okay, then it needs to be a change done. Yeah.
And I think the pandemic pushed all the companies, not only the big ones, even the small ones, into the digitalization and innovation. But there's one thing I'd like to say: if you are a company or even a researcher, please find your problems first and then build up the solution, and not the other way around. So do not use the solution and try to push it into your structure, because then you're going to end up in declining the project or ending the project. So I would then say, let's call it a day. Thank you very much to all of you to attending this webinar, to all the listeners who are listening right now.